Hello and welcome to the first video in the feedback tour. So in this series we're going to be looking at all manner of different ways of being able to provide feedback to the player. So communicating different elements there to them. So for this one, what we're going to be focused on is haptic feedback. So haptic feedback, anytime we're doing things like controller rumble, things like that, where we've got those physical sort of sensations, those movements that are being created. That's what we're talking about when we're talking about haptic feedback. And so we're going to look at how we can actually be doing that in Unity, and we're going to set up a couple of different tools and that for being able to work with our haptics. So let's dive on in and see what we've got as our starting point. So this is a project based on a couple of the other ones that you will have seen, and we've got a couple of things set up here. So one thing we've got set here is this pylon that is got this heavy mass that's rising up and then is slamming back down into the ground. So we want some haptics as we get close to this. We want something where we've got a really good solid sort of thunk sound, haptic feel that's happening at that point. We've also got a rumble zone here. So what's going to happen is while the player is inside this box, we want to have a bit more of just an ongoing continuous rumble sort of happening there. So we've got two different scenarios here. We've got something that's essentially a one-shot, and a one-shot that the closer we get to it, the more intense it should be. And then we've also got a continuous one that should be only affecting things while we're in that zone. So we've got a few different scenarios there. So we're going to set up a central haptic manager for coordinating and controlling this so that we can essentially play multiple haptic effects and be able to have it manage the merging and combining of them. And that's a key thing. We want to treat haptics here kind of almost like we would treat a sound effect. We want to be able to play it. And that's going to be the goal that we set up with this. So to begin with, let's start actually setting up our haptic manager. So I'm going to create a couple of scripts here. One is going to be my haptic manager. The other is going to be for the actual haptic effect. So I'm going to set up a haptic effect SO. So we'll have scriptable objects that contain all of the data for our haptic effects. So we'll set up a data folder. All right, so let's get our haptic manager set up, and once we've got this added in, we'll start to populate some of the stuff. So we'll start with the scriptable object here. So we'll do our usual, convert this over to a scriptable object first, and set up our create asset menu. So that has our usual menu name. So we'll call this haptic effect. And our file name, haptic effect. So if we think about the couple of things that we want to be able to do this, so we know we've got this difference in type. We've got one shot and we have continuous looped ones. So that's going to be one of the things. But we're going to have a type, one shot, and continuous. So that's good. So we'll set that up and we'll default it to one shot just in case people forget to configure it. Better to have it be something that fires off once than necessarily something that sends their controller burrowing its way through the desk with how much it's vibrating. So we want to try and avoid that. So okay, we'll have stuff for if it's one shot, stuff for if it's continuous. If we think about then for the kinds of things that we need to set. So when we're working with haptics, in particular when we're working with something like a gamepad, there's two sources usually for haptics in a lot of these. So we have a low speed or low frequency motor. That's going to give us more a sort of your ka-thunk sort of sounds. So it's going to, or vibration. So it gives you those very sort of high impact ones. It also then has a high speed motor in there, and that gives you more your sort of whirring, buzzing sort of type of effects. So we've got two different ones in there. So we need to actually be able to control each one, and we control them independently. The way we control them going via the new input system is we provide an input value that is between 0 and 1. 0 is nothing, 1 is full effect. So we need to be able to control that. And we kind of need to be able to control the shape of that. So that's something where what I would actually have is, this is a great usage for animation curves. So we would have the, we'll call this low speed curve. And we will then also have the high speed. Actually, I might just call these low speed motor, high speed motor. Now, okay, that's good. We can lay out the curves. Now, those curves, generally, it's easier, and I think the interface looks cleaner if we're working with those where those are a 0 to 1 in both axes. But for something, the duration of it could be different, you know, especially if it's a one shot, that duration might be like 0.25 of a second. So we actually want to be able to control the duration for these as well. So I want to be able to have a float duration, which I'll set to 0 for now. So, okay, we've got the duration. We have our intensity there, but we might want an overall intensity scale. So I'm going to say that we can have, we'll make this a float, and we'll say low speed intensity. So I'm going to default this to 1 because that means that at 1, whatever we draw in the curve is exactly what we get as the output. If we make our intensity value here higher, then it will scale it up. If we make it lower, it will scale it down. It allows us to just work independently with the duration, the scale of it versus the shape of it, which I think helps with being able to adjust and balance it. It gives us a bit more fine-grained control over it. So, okay, that's good. We've got our duration, we've got our low speed, intensity. Those look pretty good. So we can actually configure what those effects look like now, and we'll set this up so that we've got a couple of these effects. So what I'm going to do is I'm going to create a haptic effect for, this will be for the pylon impact. And so pylon impact is going to be a one shot, and it's going to be pretty fast because this is something where it hits and then that you know, it can be a little bit of a rumble afterwards. We want it to be fairly rapid. So I'm actually going to say that its duration is 0.25. It's high speed motor. I'm going to let it be just a flat curve, but I'm going to set the intensity to 0. So that it's doing nothing. I really just want the low speed one. And in terms of the curve for this one, I want it to start at 1 pretty rapidly, and then I want it to go down to 0 also pretty rapidly. So I'm actually going to put an intermediate point here at 0.5. I want it to be at 1. And we'll make these so that these are linear. We don't want to curve there, but then this can curve down pretty rapidly. I think it can fall off quite quickly. I think that's okay for a fall off for it. We want it to essentially hit really hard and then it fades away. That's the sort of goal there with it. Change that slope a little bit. That looks pretty good. So that looks good. Well, remember, we also want this to be able to vary with distance. So that's something as well. Where cool varies with distance. And we'll call that false by default. We'll also have a max distance then, which we might set to, let's say, 25 meters. And then we'll also have an animation curve, and this is our fall off curve. So that will allow it to fade away with distance. So that looks good. So we will allow this to vary with distance and the fall off curve. We do want it to fall off pretty rapidly. So we want a pretty rapid fall off with distance. That value can be 0. So we'll hold the intensity for a little bit, but then allow it to fade out pretty quickly. That will just allow it so that we've got a good sort of variation there. So, okay, that looks pretty good. Well, now we want to start looking at how we actually use this. So we've got our pylon. If we take a look at it, its logic is pretty straightforward, but it does know when it's actually finished and impacting. So we could easily set up here a serialize field, haptic effect SO, impact effect, because then we'll wire that up to the particular effect that we've got. So we can go here, select our effect. Then we won't be, this code won't actually work yet, but that's okay, because what we'll do is we'll write how we would actually use this. So if it's not rising, so in other words, if it's falling, then I want to be able to go, hey, haptic manager, and I want to be able to say play effect and provide it with that impact effect. And then provide it with who's actually generating that impact, who's actually the source of that. So that's going to be the moving mass transform position. So this is the interface I want to be able to have. So over in my haptic manager then, well, I know that's the interface I want to have. So that means I'm going to need to have a public static function here, play effect, that can take in a haptic effect and can take in a location. It's not going to do anything yet, but it's about connecting up that interface, and now we can start making the haptic manager actually do things. So one of the first things is I want the haptic manager to be a singleton, so I can easily access it from other places. So what I will do in that case then is I will have a public static haptic manager with a public get and a private set. It's private set, and we'll call this instance and default that to null. So that's good. For actually populating that then though, we would have void awake. So instance is equal to this, but beforehand we check if instance is already set. We return, we destroy who's ever trying to create a second copy of this, and we just output so that we know attempting to create second haptic manager on, and then we can just output who attempted to do that, just so we make sure that it doesn't happen. So that's good. So this play effect will actually then have an internal version of this. So we'll actually have void play effect internal that provides through the same information as this one did. So our effect vector3 location, so that then this static interface is able to just say, okay, it can go instance dot play effect internal effect location. Just allows us to create a nice interface for everything else, and we have a very clean interface here, so it makes that interface set up a lot cleaner. So okay, we're starting to play something, so that's cool. So we need to think about then, if we're starting to play it, we need to decide who has ownership over what's actually happening with the effect. And there's two sides to this ownership. There's working out the output for the effect at that particular point in time, and then there's working out what the actual cumulative effect you apply to the motors is. So in this case, I want the effects to kind of look after themselves, is how I want this to happen. So what I'm going to do in this case is when this comes in, I'm going to go scriptable object, instantiate effect, and this is going to be the active effect. And then what I'm going to do is it's going to then be getting tracked. So I'm going to set up a list here. And this is going to be a list. And what I want to do is I want to keep track of where this effect is actually happening and things like that. But the main thing I want to be able to keep track of here is my active effects. So that's good. So I instantiate the effect. So active effect, initialize, give it the location, and then I add that to my active effects. So that's good. So we need an initialize function that keeps track of the location. So we'll have effect location, and we could support changing that over time if we needed to as well. In this case, I don't think we need to. So we're then going to, and I'm going to go to a little bit of extra effort to ensure that this is not serialized. Effect location, just so we can keep track of where this is being played from. So it's that. So okay, we can play an effect, it will add it, sets it up, gets it ready for us actually running. So now in update, we can start actually ticking these effects. So we can say, okay, well, for, and I'm intentionally using a for loop here. Index is equal to 0. Index is less than active effects count plus plus index. So then we grab our effect. So now that we've got that effect, what I want to be able to do is, because remember, we've got our two motors. So we've got our high speed, low speed motors. So I want to be able to go, okay, well, effect tick. So when I'm having things that are internally being ticked and they're getting ticked from something else's update, rather than using update as the name in those ones, I always use something different just to avoid potential confusion there, because it's not something that's getting ticked by Unity or updated by Unity. It's something that I'm updating manually, so I always call that a tick. So we're going to tell it to tick. Now our haptics, because we've got distance, we need something that's we're linked to that keeps track of the distance. So I'm going to be able to, actually our camera, we can just use the camera for that. But I might make it that that's an actual thing that gets passed in. Of camera, main, transform, position. Just because I think it would be good to be able to potentially at times override that. So, okay, we're ticking the effect. That's cool. And we need to get out of that our motor data and everything though. So this is something where what I would do is float low speed motor, float high speed motor. Not that I need to actually initialize them, but force of habit, high speed motor. Now I also want to know if this effect is done. So I'm going to make it that these effects return true when they are finished, when they are done. Because what I will do is in that case, I'll say active effects remove at index, and then I just subtract from index. So in this case, tick the effect and clean up F finished. Actually, I'm going to make that low speed component and high speed component. So, okay, this is good. We can then set up our interface. Again, I'm following this approach I like to do of implement the code to use the thing before I actually implement the thing. That way then I know what I'm building towards. So in this case, 3 receiver position, out, float, and we'll just call that low speed, and this one will just be called high speed. All right. So first thing I need to do is I need to update the progress. So that means I'm also going to have here a system non-serialized float progress, which again, in initialize, I'm going to force that to 0. So first thing we do is we update our progress. So progress plus equals time.delta time divided by duration. This way our progress just goes from 0 to 1, so that works out well. So we can tick it. So update the progress. Now we're going to grab out the particular values for the effects. So, okay, well, low speed is going to be our low speed intensity times by low speed motor, so that curve that we evaluate at progress. High speed is going to be high speed intensity times by. So the actual evaluation process is quite straightforward, but we also have our distance fall off. So we need to hook up our distance fall off. So I would check beforehand, well, if it varies, actually we can do distance factor is 1. If it varies with distance, then we get receiver position minus our effect location. Get the magnitude of that and divide that by that max distance. This is then something we can feed in to get our distance factor. So we'd be able to say then distance factor is equal to fall off curve evaluate based upon that. We could also be checking this distance here. I'll actually put this into a variable distance, because what I would want to do is check if we're over the max distance. So if distance is greater than max distance, it can be greater than or equal to max distance, then the distance factor is 0, otherwise we use the curve. So we're calculating our distance factor. This will allow it to fall off, and then we just add this in here, because if we're not varying with distance, we're scaling up by 1, so that will work out fine. Then, okay, we need to check if we're done. So if the progress is greater than or equal to 1, then if the type of this is one shot, so if type is equal to eType one shot, then we return true. Otherwise, we set progress back to 0 and we return false, because if it's continuous, we start back at the beginning. and we go from there. What I would probably do actually, if we wanted to have a, no, actually, because it's clamping at 0, I was considering we could have a little bit of carryover. There's probably no need for checking for carryover. Check if we are finished. So, okay, we've got something that should be outputting these high and low speed components. So this is something where what I'm going to do is just log out low speed and high speed. And we want to just see, is this actually working? So we want to be testing periodically with stuff. We don't want to leave it go too long before we actually check and make sure that things are working. So our haptic manager is all good to go. So let's run this. And we would expect to see, and we can see big pulse of stuff coming through there. Intensities were quite low. When I'm really close, those intensities are quite high. But if I run away, intensities are much, much lower. So that's good. We've got our components coming through. So then what I would do is we need to work out what is our overall motor amount that we're applying. So low speed motor is equal to 0, float high speed motor also equal to 0. And then what I would do here is low speed motor is a mathf clamp, and we could do low speed component plus low speed motor, keeping it between the 0 to 1 values. Now this is working on the assumption that we've got only, we're not playing huge amounts of overlapping effects, which we generally don't want to, because if we've got huge amounts of overlapping effects, people aren't easily going to be able to distinguish them. Our resolution for things like that is not going to be super fine. So generally we want to not go too overboard with that. So I want to bring in the input system, because then what I can do here to actually play these is, so you can go gamepad, current, and then set motor speeds, and then we can set low speed motor, high speed motor. I'm also going to set up an on destroy here, where that is just going to run this, but set to 0. I want to try and avoid leaving the motor continually running. It's not really going to be great. So I'm going to leave the controller on my desk and hope it doesn't manage to go flying off of the desk. So it's impacting. Now it's very low at the moment because we're a distance away from it. Get quite close to it. Get a bit more of a noise, and if I bring it closer, might be able to be hearing it there. But so we're getting a really solid ka-thunk there from it. And I think we could actually ramp that up a little bit more. And this is something where we could experiment with this of, okay, well, that effect, it's okay, but let's actually make it that, maybe we want to have that intensity not fall off as rapidly. So that's something where we could actually increase that distance. So if I ramp that distance up and then run this, then it will impact. So it's giving an impact a lot closer. We'll try and see if we can hear that. And then if I get quite close to it, we get a much more solid impact from it. So really simple way of adding in the effect, but it allows us to get that nicety of, well, it's varying over time and it's varying with distance. Someone could use that for actually navigating closer to it based upon that intensity, which is cool. It means that it's being able to be used for, actual action someone's trying to achieve in the game, which is great. So, okay, that's our pylon. Now we've got our rumble zone. And this one's going to be an interesting one because, okay, let's create another haptic effect for that. So haptic effect, this is going to be rumble. So this is going to be looping. So it's going to be continuous. And I'm going to say that this is happening over a 2-second duration. And I might make it that the low speed is not particularly intense. So I want the low speed there, but I don't want it to be overly intense. And I'm going to, for the low speed, put in a couple of key points. So what I'm going to do is say that it begins at 0. Going to have it also end at 0. So because this is looping, I want this to be a shape that looks reasonable for it looping. That intensity is fine there. So this is what I want the low frequency one to do. I might make these just a little bit more of a gradual change there. Again, we want to design this nicely for looping, and like with a texture, we want to, when you're trying to make a tileable texture, we want this to have fairly good transitions there. It's not going to vary with distance, so I'm just going to leave these at defaults. Now, high speed motor, this I want to be going a little bit differently. So I will start it at 0 and also end it at 0 because I want to have that same setup there. But the difference is going to be, this is going to have a lot more points to it. So it's going to have lots and lots of these points. And what I'm going to say is that that is going to be 1 at a value of, at time of 0.9. So again, we're setting it up to be symmetrical because we want this to loop nicely. And this is the advantage with animation curves. It's a lot easier for actually sort of, I find, designing haptic effects for something like of this when you're trying to get these up and running, which is good. And that messed up that point. So that value is 1 at a time of 0.7. And then this one will be at 0.5 and 1. And not that we need to get these perfectly aligned time-wise, because people actually playing it are not likely going to be able to tell, but still good to get them properly set up. So again, we want to have these loop a little bit more nicely. So that's good. So the high frequency one is going to be cycling really frequently, whereas the low speed one is not going to be. So our rumble zone is going to be able to link to that effect. Now the rumble zone, it's a bit interesting because we need to be able to start and stop an effect. So that's going to change our interface a little bit as well. So we're going to go to our rumble zone, and we'll be able to say serialize field. We have our effect. We'll just call that haptic effect. So when there is someone in the zone, then we want to be playing the effect. So what I'll do is if players in zone was 0, then we start playing the effect. So Haptic Manager, play effect. So very similar to before. So we need to be able to say, here's the particular effect, location. It's not going to be applicable, but we can do this. But now, when we remove it, if the players in zone dot count is equal to 0, I need to be able to stop that effect. So Haptic Manager, stop effect. So I need to have a unique ID essentially for these effects. So one option is that when this goes to play the effect, it could just return that effect SO. So let's go with that. Active effect is equal to null. So we store this, and then we can tell it to stop the effect. So that changes our interfaces here a little bit. This needs to return haptic effect SO. Means we also need here a stop effect where we can provide it with the particular effect. And again, that would go and use our internal function. So instance stop effect internal, give it our effect. And so our one's down here. This now has to return a haptic effect, which is fine because we've already got that. So return active effect. And we also need our stop effect, which same as the before. Now this, for removing it, it's not too much to actually remove it. We would do active effects, remove, and provide it the effect. So there's not a lot that we needed to do for being able to have it, remove a specific one. But let's test this out, because what should happen is as I go into if I've linked it up to the rumble zone, I suspect I did not, so let's link that up to the rumble zone. So, okay, that's good. Okay, so now we're ready to test this, and what we're expecting is when I head into the zone here to start getting the effect, but I'm not. And the reason I'm not is because players in zone needed to be checking if it was equal to 0. Really easy to miss, but that was going to be stopping the effect. So now we'll test with it having more correct logic there in it. So we head over, no vibrations yet. We head in. You can hear, likely, that it's starting to vibrate. As soon as I leave, stops. So we've got the effect continuously happening, and as soon as I step out of the volume, it fades. And not that we've intentionally put anything in there to cause it to fade, it's actually just an artifact of being how the motors work, that there is going to be a little bit of latency there with that. So we've got our effects. We can play one-shot ones, we can play continuous ones. Let's see how these work if we actually have these, happening, overlapping. So I'm going to take this pylon. So we've got pylon 1, and we'll have pylon 2. And pylon 2, I'm going to move over into here. So I want to confirm. I suspect it will work fine, but I want to confirm that. I want to make sure that when I head into here, so I'm already getting the vibration from being nearby. And then if I go into here, I'm getting the continuous vibrations. And I do get a bit of a pulse, but it's not overly noticeable, and that's because of the intensity of the other vibrations. And this is something that's an important thing with haptics, that you do need to carefully balance sort of the intensities there with them, just because it's going to be hard to differentiate between them. So what I would actually do is I would take the high speed intensity and I'm going to drop that actually quite low. And same with the low speed one. So both of them, really just dropping them down in intensity so that the impact of these other ones can be felt over it. So I'm getting a bit of vibration, and it means then that ka-thunk from the pylon actually can feel that. So this is something when you're setting up haptics, don't view it as, with sounds, you can have quite a few different sounds playing and we can distinguish between them fairly readily. We're not going to be able to with haptics. There's not the ability to resolve and to actually distinguish between things. So think about the levels that you're setting stuff at and think about how many different ones you might be playing at the same point in time. Try and keep that low and maintain a bit of a balance there between them. Have, some ones that are, if they're continuous, have them a fairly low intensity. Save your really high intensity ones for big impactful things where you need to be getting the player's attention. Don't have everything be a really high intensity, because all it will just feel like then is the controller is just making a lot of movement. It's not going to feel like there's actually tied to the action, and you want it to feel like it's tied to the action. That's the whole point, is to make it so that it feels more connected. But we've got our setup. We have a haptic manager that we can throw into projects. We've got some examples there with our rumble zones and everything, which I'll make that a prefab as well. And we also have our haptic manager good to go. So it's something we can throw in. With our effects, we know we can adjust the duration. And that makes it really easy for just changing these. If we want it to be something that lasts for a shorter or longer time, we can easily do that. If we want it to vary with distance, all of these things we can actually do built in just with some tick boxes now, because we've got those being combined. Now, if we had a lot of effects, there is some things we could do here where we could normalize the relative effects. We could potentially do that. So take the intensities of all of them, look at normalizing it, and so that you can try and maintain a bit of resolution there. But if you've got that many effects where you're needing to normalize it, you're probably not going to have that resolution there anyway. So better to just keep it to be a measured small number of effects, so that it's going to be most effective and most noticeable. That's really what we're after with the haptics. Now, this is tied to using the new input system. And it is showing using gamepad, but there are similar things for other devices and that as well, or if it's in virtual reality for the controllers, we've got similar ones there for the haptics for them. If you're wanting to do haptics, I really recommend using the new input system for it. It's a lot more work trying to do haptics without the input system. With the input system, this code that I've written, like I'm using it with a Xbox 360 controller, it would work with a PS4 controller, exactly the same. No code changes, plug in, it works. So I recommend using the new input system. And the other big thing I recommend, just because I've seen what will happen if you don't, is make sure that you're always resetting the motor speeds back to 0 when things are done. I have heard many a story of things where controllers have gone and borrowed grooves in desks because they've been left for so long just vibrating for testing setups. Whether true or not, it's not really going to be good for the controller or the desk to be left there vibrating like that. They're not designed for such long-term continuous operations. So keep it that you're resetting the speeds. That's why I designed this, so that its default effectively is going to be going to 0. If there's no effects, it will always bring it back to 0, and on destruction it brings it back to 0. So keep that in mind as well. Just from, again, a user experience point of view, it can be really frustrating as a user if something happens in the game and everything keeps vibrating when it's not supposed to. That can be really annoying. You have to unplug controllers, replug them in often. It's a bit messy. So keep that in mind when you're setting up the stuff with the haptics as well. Thanks folks, I really hope you found the video helpful. If you're looking for the code for the project, the code as always is available up on GitHub, and the link to that's in the description below. Full code for the project is there. You're able to use this for any of your own projects there. So dive in, make use of it. And if you've got questions, chuck in a comment below. You'll also see there's a link for if you're wanting to submit questions for a Q&A video, then chuck your questions in there as well. If you have found the video helpful, do chuck in a like and subscribe. It really does help out the channel. And if you're looking for other ways to support the channel, I do have a Patreon, and the link for that's in the description below. Bye.